Hello, and welcome to RISC-V online webinar. My name is Jason Lin. I'm here with my colleague Hsieh. We are senior technical marketing managers for Andes Technology. Today we are going to talk about the next generation RISC-V processors, the AndesCore 27 and 45 series CPUs. In today's agenda, first I will give an overview of Andes Technology's V5 processors. Next, I will talk about the recently available 27 series. And most importantly, the MemBoost features for memory access performance improvements. After that, for the second half of this webinar, Carol will talk about the upcoming 45 series with even higher performance and operating frequency. The target application for 27 and 45 series CPU cores and summary. Let's begin with an overview of Andes Technology. Andes Technology is one of the founding and platinum members of RISC-V Foundation. It shares some test groups in the foundation and actively contributes its technology to the foundation. With more than 300 customers worldwide, the production of SoCs that embedded with Andes CPUs is more than 1 billion pieces per year. Andes Technology has been in the CPU business for more than 15 years. It is also a public trading company in Taiwan. Our R&D team is very experienced in CPU design, and the core members are from the top CPU companies in the world. Now for the overview of Andes V5 processors. V5 is Andes Technology's latest instruction set architecture, which supports RISC-V technology. And shown here are the Andes 25 series CPU cores. At the door left, the N25F is a compact and high-performance RISC-V core for bare metal and RTOS applications. D25F added DSP instruction extension for applications that require signal processing. On top of that, A25 added memory management unit for Linux applications. Furthermore, the A25MP is a multiple core processor solution that includes up to 4 A25 cores. It also includes a level 2 cache controller with hardware cache coherent support. These are 32-bit processors, and at the right are their 64-bit counterparts. The 25 series are 5-stage pipeline and can run up to 1.1 GHz at 28 nanometer process. The 27 series includes A27 and AX27 processors. It is based on the successful 25 series, which has been licensed by many companies. The most important addition in 27 series are the MemBoost features that I will introduce later. Also, there is NX27V that supports RISC-V vector extension. Vector processing is capable of processing very wide data in one single instruction. So it is very powerful for processing that set of data. I will not talk about vector in today's webinar. However, we do have a separate webinar for it. So if you are interested, then please follow our webinar announcement. Next to the 27 series, the 45 series takes their performance to the next level. They have redesigned microarchitecture that supports dual issue execution with H-stage pipeline, and they are capable of running up to 1.2 GHz at 28 nanometer process. Also in the V5 process lineup, there is a 2-stage pipeline N22. It is very compact and lightweight, which makes it highly suitable for batch control tasks. Now I will talk about the 27 series cores. 27 series is based on the mature and successful 25 series design. It supports the same RVG-CMP instruction set and delivers the same scalar performance. On top of it, it added the MemBoost features and the programmable physical memory attribute support. The programmable PMA feature that develop defined address space as either memory region, I/O region, or empty regions. Furthermore, memory region can be specified as cacheable or non-cacheable. For cacheable region, it can further be specified as write-back or write-through. Their cache time update policy can also be specified. As for the I/O regions, they can be bufferable or non-bufferable. For the empty regions, you might be wondering why there's need to specify non-existent space. Actually, whenever there are instructions fetched from these regions or data those stored to release the regions, the CPU will assert access for right away. Therefore, they are very useful to capture software program runaway events or to detect system hardware errors. Next, in the 27 series, the main addition is the MemBoost functions. It consists of several features that helps boost the performance for accessing system-level memories. This is important as compared to the on-chip embedded memory, because system memory usually takes very long time to access. With the MemBoost feature, it added memory bandwidth by more than 2 times and cut the access latency by half. I will talk about the details in the following slides. First in MemBoost is data cache write-around. In typical operations, cache time are being allocated either on memory reads or writes, and they will be evict data when they are not being used. However, if we examine the operations in more detail, you might notice that in some cases, these allocate and evict operations are not desirable. For example, in the case of large volume data movement, such as memory copy in the software, data should move directly from CPU core to system memory without being allocated in the data cache. With this data cache write-around feature, CPU hardware will automatically detect these sequential data movements and write around data cache instead of into it. Therefore, avoid unnecessary cache write-backs and improves the cache hit rate. Next is instruction and data prefetch. Prefetch is nothing new. However, since prefetch is a caching game, we would like to improve the odds that the instruction and data CPU prefetch are those will be used data, and not the other way around. In the 27 series, the instruction and data prefetch will make better prediction on whether to prefetch the next instruction line and whether the data is streaming based on the past access patterns. Thus improves the utilization of the cache. In addition to cache performance, CPU bus interface is also important to the overall memory performance. With multiple outstanding memory requests on CPU bus interface, transactions can be issued even before the previous transactions are completed. This is essentially multiplied the bus utilization by many times. Furthermore, the completion of the transaction can be out of order, meaning that slow transactions will not block faster transactions on the bus. Considering that the first SDRAM access usually takes 100 to 200 cycles, this can significantly improve the memory performance. Also in MemBoost is dedicated instruction and data bus interface. When core and data reside on different memory devices, separate bus allows independent access to instruction and data memory without conflict with each other. On top of the multiple outstanding memory request features, this improves memory performance even more. The MemBoost features are also useful for systems with many CPU cores. In this example diagram, we have many 27 series cores connected together with separate instruction and data bus to core memory, data memory, and I/O. Many core systems are getting more important as we see more and more customers use many CPU cores in their designs, such as for over 30 CPUs, for over 100 CPUs, or even more than 1,000 CPUs. Also, the programmable PMA can be used to define uncached regions for them to communicate with each other without software coherence efforts. 27 series also support many cache time control instructions, such as cache line invalidate, cache write back, cache line fill and lock for their fine-grained cache controllers. So these are the 27 series features for today's webinar. Next, I will let KY introduce the 45 series. Over to you, KY.
Okay, thank you for Jason's introduction to our 27 series. Now this is my turn. This section I will introduce Andes 45 series superscalar RISC-V CPU IP cores. I'm KY Hsieh, a senior marketing manager of Andes. First, let's look at the 45 series overview. Our 45 series is the 8-stage in-order dual-issue RISC-V core. The pipeline stage is showing the right-hand side. You can see we have total 8 stages in the old pipeline. And the 45 series, all series support our ND-Star V5 instruction set architecture. That include RVGCN and the P extension is SIMD-DSP. It also has a MMU capability. So if you need it run Linux, we also support that. And all our CPU cores support our ND extensions. Our 45 series can dual issue most instruction pairs. There are some exceptions. For example, if your two instructions are 2 multiplier or floating point, or DSP or load store, or some spatial dependent ALU instruction pairs, then this cannot be issued together. However, user no need to worry about that because our compiler will help you to resolve this problem. We also have we call the let ALU this kind of the mechanism, which can enable zero cycle load use penalty. I can express more in our let ALU. In some cases, the source data for ALU 0 here may not come out on time. Usually, CPU will stop pipeline until the data ready. However, in our 45 series, our let ALUs can resolve this situation. Pipeline no need to wait to be stored. The let ALU will execute the instruction at a later stage. So this can improve our ALU instruction execution efficiency. For the ALU 0 and ALU 2, these pipelines execute the first instruction of the dual issue pair. If an instruction is executed in ALU 0, then ALU 2 has no operation, or vice versa. For the ALU 1 and ALU 3, the same. They execute the second instruction of dual issue pair, the same as the previous one. If an instruction is executed in ALU 1, then ALU 3 has no operation, and vice versa. We also have MemBoost for memory subsystem. MemBoost already introduced by Jason in previous section. I will show some our 45 series MemBoost features later. And we also have support low power dynamic branch prediction. Our 45 series processors predicts an entire basic block on each branch prediction. A basic block is a series of instructions that contain only one branch or jump instruction at the exact point. The 45 series access branch target buffer once for the basic block. Compared to traditional branch prediction, it will access a branch target buffer for each fetch block. So the power consumption on our new branch prediction can reduce the power very significantly. We also support 9 data access. Our multiplier you can see here. If you compile, our multiplier can be configured as fast or small. At this pipeline stage, you can see our multiplier here is fast, so it's only need 2 cycles. If your gate count or byte area is a concern, you can configure your multiplier as a small one to save your gate count. On this page, I can see our function block diagram of 45 series. For virtual memory, we support the shared TOB from 32 to 512 entries. For instruction and the data TOB, there are 4 or 8 entries. Regarding the physical memory support, we support the physical memory protection, PMP, up to 16 regions, and also has a programmable physical memory attribute, PMA, up to 16 regions. PMA, our previous section, has a very detailed instructions, introduction over there, so I won't repeat again. For virtual address and the physical address bit, you can see here for the virtual address mode, RV32, we support the SD32. The physical bit here is 34, and we also support RV64. There's the SD39 and the SD48. The physical address bit is 38 and 47 respectively. All CPU cores here support machine and user mode. You also can select supervisor mode if necessary. For level 1 memory, we support instruction and data cache. The size from 8K byte to 64K byte. The cache line size here is 64 byte. We support 2-way or 4-way set associative, and support optional parity or ECC error protection. We also support instruction and data local memory, IOM, DOM. The size support from 4K byte up to 16 megabyte. There's all SLA interface. It also has a step port, so you can access the data local memory or instruction data local memory from bus masters. It also has optional parity or ECC error protection. For MemBoost, actually, Jason already has introduced MemBoost. Here I summarized for the 45 series MemBoost. It has an instruction and data prefetch. It supports non-blocking load store. This includes multiple outstanding bus requests, out of order transaction completion, and it also allows software control prefetch. For data cache, we support write-around mode, and for the bus interface, we can configure our bus interface as a separate instruction and data buses. For interrupt, we support the platform level interrupt controller, we call it PLIC. Each external interrupt source can be assigned its own priorities, and each interrupt target, that means a RISC-V processor core, can select which external interrupt source it will handle. PLIC routes the highest priority interrupt source to the target processor. In our 45 series, we support over 1,000 interrupt sources and up to 255 interrupt priorities. And we also support up to 16 PLIC interrupt target. Besides the standard PLIC, we support enhanced interrupt features like vector interrupt dispatch. The vector interrupt dispatch allows the interrupt target to receive the interrupt source ID without going through the target claim request protocol. These features can shorten the latency of interrupt handling by enabling the interrupt target to run the corresponding interrupt handler directly upon accepting the external interrupt. This can improve the total interrupt handling efficiency. For the bus interface, 45 series is XI 64-bit mass port, and we support the synchronized N21 core versus bus calculation. For debug, each CPU core can support up to 8 triggers and also has exception redirection handling. We support the standard 4-wire JTAG or 2-wire serial port JTAG interface. We also support our unique technology we call Codense. Codense is our code compression technology on top of the RISC-V extension. For power management, we support QuickNap, which is a logic power down and SRAM in intention. We put the 30-bit in the tech SRAM instead of the DFROF, so it can eliminate the need to flush the data cache. We also support the power break. Power break is a digital adjust power via stalling pipeline. User just use the software to control the gating clock. You can run the 100% full clock rate or low down to 1/16 of the normal system clock, so it can reduce the power significantly. We also support the WFI, wait for interrupt. WFI provides the hint to the implementation that the current heart can be stored until interrupt might need service. Execution of the WFI instruction can also be used to inform the hardware platform that suitable interrupts should be routed to this heart. And we also support this hardware stack safe. It's a hardware stack protection mechanism. You can protect your stack by hardware. Usually, stack should be maintained by software engineer. For the very large SoC system, protect and maintain stack is sometimes a very huge burden to the software engineer. Our stack safe using our hardware mechanism that can reduce software engineers' effort to maintain the stack from overflow or underflow. For performance and speed up, our target frequency can run up to 1.2 GHz at 28 HPC plus this process node. In the worst case, our benchmark here, you can see the call mark for M45, which is 32-bit, is up to 5.4. And for NS45, is a 64-bit, can up to 5.38. For DMIS, the numbers showing here are non-inline number. For M45, can up to 2.89. For NS45, up to 6.14. For in-bench IoT, it's a new benchmark. For N45, can run up to 2.68. For NX45, can up to 2.77. Here you can see, compared to the 25 series, our 45 series is a dual issue, has is around 50% faster than the single issue 25 series. The lineup, our N45 and NS45 is our baseline CPU cores that can support high-performance embedded system. If your system needs a DSP, our D45 and the DS45 can support P extension. That means the DSP and CMD. Andes is the only one RISC-V CPU IP vendors can support P extension. For application processor, we have an A45 and the X45, which has a MMU that can support the Linux applications. And all our CPU cores will be available at the Q3 of this year. The target application of the 27 and the 45 series looking for AI and deep learning, AR, VR, 5G, networking, storage, video surveillance, ADAS, vehicle to everything, we call V2S, in-vehicle infotainment, IVI, and more. In summary, our 27 and 45 series extend our ND's success from edge to cloud. For performance and extensibility, we have a leading PPA and a code size. We have a rich data processing in P extension, V extension, and ACE. P extension I just mentioned is a DSP CVD. The V extension is a vector. Our new NX27V will be introduced at the next webinar. And the ACE, our ADIS customer extension, is our power tool to help customers define their own instruction set. The ACE already introduced at the previous webinar. If you are interested in ACE, please check our website. For configurability, we have very flexible configuration for rich features. Our CPU cores have many features. You can configure what you need depending on your system requirement very easily. Based on our 15 years developed in our compiler and the source stack, our compiler optimization and the source stack right now are very mature. And our ND side IDE is a very powerful tool, has a very comprehensive features that can help you to design our CPU core in your SoC. Okay, that's all I have, and thank you for your listening. And if you have any question, please mail to us. Thank you again.